Today I'm going to talk about teaching soundscapes in the Brazilian Pantanal and the benefits of integrating music and science education. But I wanted to start off by noting that at the General Assembly this year, our incoming president asked this question of how do we make music education interesting both for university professors and kindergartners. And this is a fundamental question of our field and of a lot of fields, and I think it's a really important starting place for us, and I'll hopefully try to answer parts of it in this talk. But before I really get into things, I wanted to change my title a little bit because I found it a little bit misleading. I said teaching soundscapes in the Brazilian Pantanal, the benefits of integrating music and science, but that's not quite right, because really what we're going to do is integrate science into music education, and that subtle switch of word order is actually, I think, really important. So I'm going to start off by addressing some of the major challenges facing music education today, and then I'll describe our Pantanalventura Sonora project and some soundscapes stuff and how it integrates into music education, before I'll go into a couple of examples of how music makes science and math more accessible. So starting off with challenges in music education today, there's some obvious cultural barriers to music education that are ongoing. These have been present for a very long time, but these include classical music education being just unfamiliar ground for people generally in lower socioeconomic brackets. Western classical music, especially like Beethoven and Bach and Mozart, is really unfamiliar outside of really narrow Western upper-class context of culture. Both rural-dwelling people, so too distant from cultural hubs, and urban people who are often in areas of and experiencing poverty, in areas where music lessons are in high demand, both of these sort of different demographics are held back from music education. And finally, there have been some solutions to these problems with music education, these barriers, things like El Sistema starting up in Venezuela, and the Sphinx organization in Detroit and other places. And then obviously there is a lot of grassroots programs, rural orchestras that have really filled in some of the gaps there. But this is a major and ongoing problem for us. The value of music education is great. There's intrinsic value in music education, that is that we are teaching children music, and music is in itself valuable. So the education is valuable because of music. There's a lot of extrinsic values to music education, though, including critical thinking improvement, math and science score improvement, emotional stability and psychological health improvement, potentially. These are all sort of debated in the literature, but there's a healthy bit of evidence that these are all potential extrinsic positive values of a good music education. However, in spite of that, funding is being cut in many districts and countries as people divest from music education in favor of other subjects that are considered more important, like math, science, and English if you're in the United States, or history, whatever other native languages in whatever other countries. So these sort of core subjects have clearer deliverables in terms of right and wrong answers. They're generally testable, and they have obvious, clear implications for sort of society after school. So one of the options is to, instead of dealing with this funding issue sort of head-on and getting more funding for music education, is to integrate music into the so-called important subjects. However, that is not necessarily super easy in itself. Scientists aren't all musicians, so science teachers can't all just immediately bring in music into their classroom. And even with integration into core subjects, clear deliverables, connection beyond the very superficial, like let's play a song in English class, is actually pretty difficult. And finally, these sort of approaches actually devalue that intrinsic value of music education, which is the music itself. All right, so the second part of this, I'm going to briefly describe Pantanalventura Sonora and then talk about soundscapes. This natural area that we work in is the Pantanal. It's sort of in west-central Brazil on the border with Bolivia and Paraguay. And this is an area that's sort of renowned for its natural beauty. It's a bunch of swamps and river systems. And it's also a home to a bunch of rare and endangered and threatened species, and has been an important conservation area because of that. So our program, Pantanalventura Sonora, sort of has 6-ish parts. That's listening to music and realizing the ways that composers are actually using nature in their music. The second is listening to nature itself and then trying to get the inspiration that composers had. Then we talk about ecology and cycles in nature before we go into the physics of sound, and those two are much more science-y. And then we talk about composition and techniques of especially contemporary composition before we actually have the kids do a performance that involves some level of improvisation and some level of composition that they've actually come up with. And this is sort of the result of that. One of our students attempted to replicate the sound of this Plumbeus ibis on her bassoon, and there's some complicated transcription that she had to do in order to do that, and eventually played this song just like the bird. And there's more to that, so maybe not just like the bird. And this is our field performance on the river's edge in Porto Jofre in the Pantanal. So this is sort of a big project that covers a lot of ground of science and nature, but it's principally a music project with science sort of built into it, not a science project with a bunch of music built into it. And much of what this project relies on is this concept of soundscapes. Soundscapes are just a representation of all of the sound in your landscape around you. There are three types of sounds, sort of broadly speaking, that we usually encounter. Biophony is sounds produced by natural, like wild animals and plants. Anthrophony is sounds produced by humans and man-made objects. And geophony is sounds of the earth, so earthquakes and also wind and water. The essence of soundscape analysis is really understanding the difference between all the different contributions to all of the sounds around you. And this is something that's available not only in these really pristine natural areas, but soundscapes are also really interesting to study in very, very urban areas. So this is a way of breaking down that urban-rural barrier and also accessing some pretty complex musical ideas. So I'm going to give two examples sort of briefly here on how music makes science and math more accessible. So there's a lot of examples of soundscapes specifically being really, really productive ways of studying science. For math, we can study things like pitch and amplitude and timbre, and we can move all the way through to Fourier transforms and creating spectrograms from waves, which requires some pretty complex calculus. In biology, we can start off with these really basic Lotka-Volterra models of cycling populations of predators and prey in nature, and get to these extremely complicated biodiversity from sound diversity arguments that depend on a thorough understanding of diversity and of modeling of how ecosystems work. Then we can also do things with physics. There's different types of waves. Waves form light, sound, gravity. There's particle waves, and this is an easy way of accessing what a wave is like is by understanding it through our ears, not through our eyes. And then finally in geology, actually much of what we know about the inner earth we know from sound waves that penetrate the inner earth and from other types of waves. In the form of earthquakes, we can also measure things like sediment deposition and hear things like wind and water flow. So just an example from math, this is an expression of sine waves at various different frequencies and actually the same frequency but different amplitudes. When you add them together here, if you add two waves together, you can increase the amplitude, which is the equivalent in music of increasing the volume. If you increase the frequency, you're actually increasing the pitch of the sound wave. And this is something that's just a simple plot of sine of x on a Cartesian coordinate system, which is something that a lot of our students were learning in high school. Of course, you can also make much more complicated waveforms by introducing a series of sums of sines and cosine functions in math. And when you create these different, more complex waveforms, you actually are controlling the timbre of the sound and making the sort of tone of the sound different. And this is a way of explaining what these waves mean that mean something to musicians that might not mean quite so much if you're just looking at it in pure math terms. So finally, when you take a soundscape, you actually transfer it into frequency space, which is on the x-axis we have time, so going from left to right we have time, and then on the y-axis we just have bands of frequency. And so at any given point in time you can see all the different frequencies, all the different pitches of music or sound that's happening at the same time. And this is an easy way of sort of analyzing what sorts of frequency bands are being activated at different sorts of times. And of course, this is what we actually did with our students. So this is our student who took the Plumbeus ibis and tried herself to replicate the Plumbeus ibis's call and created sounds that were actually very dissimilar to it, not very similar at all. The black boxes here surround her attempts to recreate the sound, and the dashed boxes are the Plumbeus ibis's call in nature. And there's a lot of extraneous stuff like that we would call noise, and this is actually something that allows access to higher level mathematics and something that I work with in my paleontological applications as well, noise reduction. Of course, full soundscape ecology based on the complexity of acoustic signatures is also possible, and this is something that we're just beginning with. This is some research from Krause and Farina in 2016, but this sort of application can be replicated in the Pantanal, and we can actually use the students of music to help separate the differences between geophonies, anthrophonies, and biophonies in our recordings in order to sort of track ecological diversity and ecological health through time. And that's really important for this region. This also has potential machine learning applications in the future, which is really sort of cutting-edge scientific research. So, in addition to all of this, we're also making advanced music more accessible. We're not only teaching all of this stuff about science, but really the point of this is to teach modern music methods, composition, and improvisation, and using nature just as the inspiration for that. This is something that actually gives us more creative thinking in the field. It allows us, it's a challenging thing for students, but it also offers opportunities to give more clear deliverables musically in terms of scientific learning, and it actually helps us increase the intrinsic value of music education because music students are feeding off of scientific ideas rather than scientific students feeding off of music ideas. So all in all, we've gone through some of the major challenges. We've talked about Pantanalventura Sonora, and now we're talking about two examples of how music can make science and math more accessible, and how all of this is actually making music, complex music, more accessible to our students. Right now, we're working on ways that we can harness the powers of online learning and use this to do a place-based program of telemusic using soundscapes of where you are around you. And this is something that we'll talk about more in Alex's workshop that we put together. We're also working on advancing the scientific and math learning agendas of this project in the future, expanding to new locations in person. As I said, soundscapes are things that you can use in literally any background. You can use this in a very urban setting or rural setting without any issues. And finally, we're working on still ways of evaluating the different types of program and how they affect learning in terms of both science, math, and music. So just to reiterate here, some of the major challenges facing music education today are a number of cultural barriers and funding issues, and there's a lot of solutions to these. And one of the solutions is core subject integration. And instead of integrating music into core subject, what we're trying is to integrate core subjects into music education. And what we think this does is actually help revalue the intrinsic nature of the importance of music education as music. We've taught several versions of this, and we're working on more versions of this in the Pantanal and outside the Pantanal. But overall, nature seems to make these high-level contemporary music ideas accessible, and nature's soundscapes also help make very, very basic to very, very advanced math and science more presentable for students and teachers of all ages. So how do we make this interesting both for university professors and kindergartners? Well, this is one way that we've found a solution to this problem. We've taken science and integrated it into music education in the Brazilian Pantanal, and we've taken full advantage, I think, of the nature around us down there in Brazil, where we spend a good part of each year. And that's sort of what we plan on doing moving forward. I'm happy to talk more about different ideas of how to integrate science into music education. I think it's an important way forward for all of us. I also think that it's sort of accessible to all levels of music teachers, and we should try to make music accessible to all levels of science teachers as well. So with that, thank you very much for your time. I really appreciate it, especially in these very difficult times of COVID, and thank you to the organizers of the conference who have managed to get all of this together and online.